In this video, we're going to be talking about exponential and logarithmic equations. So hopefully you've already looked at several examples of these, but we're just going to do one more. And as it says in pink here, it's important to remember that unless you get rounding instructions, you should just leave your answer as it is. Don't write a decimal approximation of your answer even if it looks like, natural log of 2 over 3 or something. That's fine as a final answer. But if you do get rounding instructions, then of course you should use a calculator and get an exact answer to the appropriate number of decimals. So let's solve for x or state that there's no solution. And remember, let's think about how there can be no solution. A solution is invalid when you get something that makes the inside of any of your logarithms a negative number. Okay, so because this is just x, you can't have anything negative on the inside of this. So x equals negative 3 is not an okay answer. X equals negative 10 is not an okay answer for this. Now, if this term wasn't there, x equals negative 1 would be fine, because then negative 1 plus 2, that's positive 1, check. Or negative 1 plus 12, that would be positive 11, and that would also be fine. So when we're trying to determine whether there's a solution or not, the key is these terms on the inside of the logarithms, when you plug in the value for x, they all have to be positive. Okay, that's the check. Now, let's talk about how we're going to solve this problem. So this is a logarithmic equation, and as you can see, these are all log base 5, log base 5. So when you are trying to solve an equation like this, you want to collapse all your logarithms together. Okay, so when logarithms have the same base and they're connected with plus or minus, you can put them together. So let's start by using one of our laws of logarithms on the left. We'll leave this term over here on the right alone for now. And remember that addition of logarithms is the same as multiplication on the inside of a logarithm. So instead of having log of x plus 2 plus log base 5 of x, we can just multiply these two things together and put them inside the same logarithm. So that's log base 5. If we distribute this x, we'll get x squared plus 2x. Okay, so far so good. And now, because both the left and the right side of this equation are log base 5, basically those cancel out. So I'm going to show you how that works, but in general, if you have log base 5 and it's just a single term, it's very important that you only have a single logarithm. Unlike here, you can't just cancel out all of these logarithms. You have to have a single logarithm on the left and a single logarithm on the right. But basically what we're going to do is say, put both of these, the left and the right hand side of this equation, as exponents on whatever the base of the logarithm is. Okay, so the base of this logarithm is 5, so we're going to sort of let both sides of the equation be an exponent. Because if this is equal to this, then 5 raised to this number should be equal to 5 raised to the same number, right? But then when you do this, one of the rules of logarithms says that if you have an exponential function that matches the base of a logarithm, those cancel each other out. So in effect, those logarithms are just going to cancel each other out here, right? Like, you don't necessarily need to show this step. You can just sort of drop the logs on both sides and just get what's inside of the logarithms. So now we've just got a quadratic equation, which we learned how to solve a couple of chapters ago. So we're going to collect everything on one side, right? Remember, to solve a quadratic, we need equal 0 on one side. So we're going to subtract x and subtract 12 from each side, and that's going to cancel these out, giving us just 0 on the right-hand side. And then over here, we'll get x squared minus x, or rather plus x, right? Because we have positive 2x minus x for a total of positive 1x. So now we're just trying to solve this. And you can use the quadratic formula if you want, but this one will also factor. So this factors into positive 4 and negative 3, right? So you can always double check this, right? X squared, negative 3x and positive 4x will give us a positive 1x, and then positive 4 times negative 3 will be negative 12. And then once you have it in factored form, right, you take each of those factors and set it equal to 0. To get our two answers, which in this case will be negative 4 and 3. And here's where you have to be careful to make sure that these answers actually make sense. Okay, so -4 and 3. Let's go back up to the original. If I plug -4 into this, for example, I get -2. That's no good, right? That makes the inside of this logarithm negative. And all it takes is for it to mess up 1. Okay, so this is not a valid answer. Okay, but 3 is a valid answer, because if I go and plug in up here, right? 3 plus 2 is 5. That's fine. 3 by itself, that's fine. 3 plus 12 is 15. That's fine. Okay, so remember that you have to check your answers. And in this case, x equals 3 is the only answer for us. So in general, when you're solving these logarithmic equations, the first thing you want to do is collapse all the logarithms together on each side of the equation, because then once you have a single logarithm on each side, you can just sort of cancel those out and just solve a regular equation, either linear or quadratic or whatever it happens to be. And then once you do your algebra, you get your possible answers. You have to check to make sure that they actually make sense. So in this case, x equals 3 is our only answer.